guys. My name is Asor, and I'm going to be showing us how to install ClaudeCode and then use it with open source large language models via Olama, right? So ClaudeCode is traditionally developed by the team at Anthropic, and it uses Claude models like Opus 4.6 and Opus 4.5, and any of the other Claude native models, which include Sonnet. Yeah, we're looking forward to Sonnet 5. We are at Sonnet 4.6 now. So essentially, as a software engineer, you're supposed to write code to solve tasks. So in your everyday job, you get hit with problems, and then you have to write code to be able to solve those problems. However, looking at the performance of coding agents, large language models across different benchmarks, we're seeing the capabilities of models get to the point where we can completely, should I say not completely per se, let's say up to 95%, trust models to do exactly what you've told them to do. And then the remaining 5%, we can always rely that there's a human in the loop, and you can go in there and see what the model has done, right or wrong. You can check the critical areas like the security, and then the should I say user experience, which includes stuff like load balancing and the likes, to ensure that it has properly accounted for all of that. But if we're looking at the leaderboard here, we can see we have Opus 4.5 performing at an average of 76.80 percent on the SWE benchmark, which is the software engineering benchmark. It's essentially a group of tasks that software engineers have to perform. It's compiled by experienced professionals in the field of software engineering. So without further ado, let's go over to ClaudeCode. So this is the setup process for ClaudeCode for PC. So I'm working with a HP laptop. So I'm going to be showing you how to set this up on a HP laptop. I've already set it up actually, but then if you go to this documentation page for ClaudeCode, look at this is the URL. I'll have it in the notes. Then you just copy this and then you open your command prompt. Once that is open, you paste that in and you hit install, and you hit enter rather. So we can see it's downloading. So as you can see, it says found an existing package already installed. So there's also no upgrade available because it's up to date. So with that installed, if you want to check if your Claude installation is working, you can just right after you type Claude and hit enter, and it should load up the Claude interface. Yeah, so it's working. So I'm going to just Control C out of this. All right, I've cleared it out. So we have ClaudeCode installed. The next thing we're supposed to install is Olama. Now, Olama is a tool that allows you to download open source models and then run it on your own machine. Now, they also have a cloud service where you can access proprietary models like Google's that's Gemini 3, that's from Google, Anthropic's Claude models, and then OpenAI's GPT class of models. I think we're up to GPT 5.3 right now. Let's see, I think 5.3, right? Okay, we have GPT 5.2, which is the latest that we have right now. So you can be able to access all of those models via Olama. So there are two options to install this on your Windows machine. You can either download the exe file as the executable, which is around about 1 GB, or you can install it directly using PowerShell by this command. So you can copy up this command and then open up PowerShell. So if you open up PowerShell and paste in that command, and you hit enter, and it will begin to download the necessary files and install. However, I already have it installed, so I'm not going to wait for this to finish downloading. So to check if you have an Olama, if your installation is done right, you type Olama, which is the command for the command keyword for Olama in the interface, and dash dash version. I think, all right, yeah. So the version is 0.16.3. That's the version that I have. So once you have these two things installed, the next thing you want to do is to go to the directory. For instance, if you're going to be working on a project, and so I have the folder where I do all of my projects. So let me use one as an example. Ideally, you should open this in, I would have loved to show you how to do this in VS Code, but I'm going to do that some other time. Let's look at this particular product here. So if I wanted to like use the coding agent to perform a task in this directory, maybe I wanted it to like maybe build out a new feature or tell me about the project, or maybe like we fix a bug for me, for instance, I would come over here and then type cmd to open up a terminal right in this particular directory. Once this is open, that you need to set some environment variables. So I believe that if you're a software engineer, you should know to activate or to create environments for each one of your projects, right? So I use Conda to manage my environments. So Conda activate, I think there should be an environment for local lens. Is there? Oh no, there's no environment for local lens. So I'm just going to create one now. So Conda create dash new. I'll call the environment local lens. I'll make it Python version 3 points. We have 3.14 right now. Yeah. So dash yes. I'll hit enter. Just a quick tip: if you don't understand why we should have environments, so think of environments like small worlds for every one of your projects. So your computer is essentially the world, right? It's the global environment. So now for each one of your projects, every one of them have a specific requirement. They have libraries and they have packages that they use, and they have specific versions that work for them. Now, if you take, for instance, Pandas, for instance, which is a Python library for reading spreadsheets and managing data frames, right, doing data analysis. So if you have a project that depends on Python, rather on Pandas version, let's say 3.0, right? And then there's another project that depends on version 3.1, for instance, right? You can't have 3.0 and 3.1 installed at the same time. But if you have different environments for those different projects, you can install Pandas version 3.0 in the environment that is meant for the project that needs 3.0, and then you can install 3.1 in a different environment that is also meant for the other project that needs 3.1. So that's essentially why we have environments. So just make sure that we don't have, yeah, should I say, dependency clashes, essentially. So we've created our environment. So I'm going to activate it now. Conda activate local lens, which should, by the way, local lens is a OCR product that essentially converts receipts into JSON format and presents an Excel a CSV file, editable CSV file for you to download. It's meant to reduce the amount of time that finance experts spend transcribing data from receipts and other financial documents into a CSV file before they feed into other downstream systems like QuickBooks and the like. So if you ever want to use the product, or you need me to set up something like that for you, I'm always available. You can message me via any one of my platforms. So we've activated the environment, right? So now we need to, I told you about setting up environment variables that ClaudeCode is going to use to communicate to Olama. You need to tell ClaudeCode where to find Olama and then which token to use, right? There's always an authorization token. Even if you are setting ClaudeCode normally, using the paid version, right? Me, I also use the paid version of ClaudeCode. I'm on the $20 pro plan. So if you have that kind of plan, you can always go to the Claude interface, to the Anthropic interface, that's their web interface, and generate an API token which you use to set up Claude for the first time when you want to authenticate essentially. But with Olama, you don't need a token. However, ClaudeCode needs a token, so there is a workaround for that. So let's head over to my Notion where I have a bit of notes. So there's a note on how to use ClaudeCode with an open source model. So I'll say, first of all, you need to set the authentication, the Anthropic authentication um, token to Olama. So I'll copy that and go back to our environment, and I'll set that up. Then the next one, you also need to set the URL. So this port, the port 11434 is the default port where whenever you install Olama on your PC, it communicates on port number 11,434. So what we're essentially telling ClaudeCode right now is that if you want to send any information or if you want to access a large language model, because ClaudeCode is not a large language model. ClaudeCode is a harness, it's an agent harness. That's what we call it in the industry. So it's essentially a group of prompts and infrastructure that works using the reasoning capacity of a large language model. So there are so many other tools that are in there together that are packaged into the ClaudeCode product. You have things like let's say grep. Grep is a tool that you use to search over documents using it's a text search tool that you use to find specific files, right? Then you also have another tool like let's say Globe. Globe is also used to find files. There are so many other packages that Claude Code uses to be able to do what it does. So it's not necessarily um, tied to the model. The model is like the brain, right? If you look at yourself as a human being, right, your brain is seated up in your head, but then you have hands, you have feet. If you want to walk, if you want to type on your keyboard, it's your hands, it's your fingers that do the typing, right? But your brain is controlling what your fingers do. So think about Cloud Code as the infrastructure, or should I say, the enabling environment within which the model gets to express itself, essentially. So we're going to set the base URL for Cloud Code to access any model of our choice. Then finally, the authentication key, which is the API key, which we don't have. We're essentially telling it that there's no authentication, there's no API key because Olama does not need it. But then Cloud Code expects that it be made available. So we just pass in an empty value. So with that set, the next thing is to pick a model. This is where I'm going to take you to Olama itself. So if you've installed Olama, you have it running in your tree over here, or you could always like press your menu key and type Olama and hit enter, and then the interface for Olama will open up like this, and then you would have here a list of models. All models that you see a cloud in front of them, these are models that are hosted on Olama Cloud. They are free to use. However, there are usage limits. You would have to subscribe to Olama to give you additional quotas for you to use, right? Take a sip of water. So we have the GPT OSS 120 billion parameter model that OpenAI released last year to the open source community. It was their own way of basically giving back to the community, right? So they released a 120 billion parameter model and a 20 billion parameter model. And we know OpenAI we know them for quality. So it was actually a good thing for them to have donated these two models to the community. Then we have DeepSeek from China. right? Then we'll have Quen 3, and then we'll have a host of other models. On my system, I've downloaded, let's see, 1, 2, 3, 4, 5. I have 5 open source models which I downloaded from Hugging Face. Hugging Face is the place you go to get the weights in GGUF format of any open source model, right? You download it. In one of my other videos, I showed you how to set up Olama with an open source model. So if you want to see how that works, you can go watch that video. However, in this case, if we're looking at coding tasks, right, we know that GLM 4.6 is really good. The benchmarks, it performs really well. Quen 3 is also a good one. Minimax, in fact, I have Minimax open right here. You can see the latest Minimax and how it performs alongside other models. So look at Anthropic's, that's Claude Opus 4.5, which is Anthropic's best coding model, and it performs 80.9 on the SWE benchmark. And then you can see Minimax 2.5 doing 80.2. So it's just 0.5 percentage points away from the best performing model. Then Anthropic's Opus 4.6 is 80.8. Then you have Gemini 3, right? Gemini 3 Pro at 78, and then GPT 5.2 at 80. So you can see that the open source model like Minimax 2.5 is at 80.2. Now to run this model on your machine, man, it's really, because this model is around, I think, over 300 billion parameters, right? You would need upwards of 250 gigs of RAM as well as a GPU. So it's really not practical on consumer hardware. However, the purpose of this tutorial is to show you what's possible. If you have the money and you can go get the infrastructure, then you can be able to own your system end to end, and you don't have to pay monthly subscription fees like I have been doing and many other people have been doing. I've been paying $20 a month to Anthropic for what for close to a year now. So if you don't want to do that, you can go buy a GPU and hook it up with any of the open source models. I'm looking at Kimi. Just Kimi is also a good one. It just came from Moonshot, yeah. And then it's, let's see, where does Kimi fit on the benchmarks? Kimi 2.5. Yeah, this is the benchmark. And let's look at the software engineering benchmark, or the coding benchmark. On the coding benchmark, it's at 76.8% as against the other guys, which is decent enough for an decent is actually downplaying it. It takes a lot for an open source model to be competing with closed source models. Open source basically means that they have the entire model free for you to use. However, if you now look at the memory constraints and the performance gains and losses, you see that at floating point 16 bits, you have it at 2.05 terabytes. You have to load all of this into memory. Then at 1 bit quantization, you have it at 301 gigabytes. What this essentially means, like I explained in my other video, is that, remember how in secondary school or in high school, for those of you that are not in Nigeria we call it secondary school. So remember how you would be given a question and told to write the answer in 3 decimal places or 4 decimal places. It's essentially pruning the the specificity or the level of accuracy for computations. So if you say at 1 bit, you know that if at 16 bits you have, let me just for the purpose of understanding, I'll say you have 16 decimal places, and then at 1 bit you essentially have 1 decimal place. So as you go down from 16 bits, you are losing accuracy. But then it won't mean so much if you are not in fields like gene sequencing and which other which other field requires a lot of precision? Okay, let's look at engineering, for instance. So if you're not in construction, where every single decimal spells the difference between should I say life and death, essentially, because if you get something, if you get your calculation wrong, maybe with the aggregate mixing and all of that, the integrity of the building or the construction could be compromised. But then when you're dealing with, let's say, natural language processing tasks, you can be able to tinker a bit with this level of precision and then still get similar results. The difference will not be very much. However, even at 1 bit quantization, this is 301 gigabytes that you have to load into memory. So with that said, I think I've drifted off a bit. Let's go back to, where was I? We're at, okay. So I was showing you the models. So for the purposes of this, I'm going to be using GLM 4.6 cloud model. And to make sure that I have this in memory, that's Olama recognizes it, because if you've not loaded it into memory, ClaudeCode will not be able to see it. So to make sure that you have this in memory, you need to use the model at least once, so that Olama ties your account essentially to that particular model. So let's go back to the terminal and see which models I have on my system. To do that, you say olama list. So as you can see, I have the Point 3, I have Minimax M2 Cloud. What else? The LFM. This is an interesting one. If you want to run language models embedded in your mobile apps, you should look at Liquid FM. I'm digressing again, but I'm passionate about this stuff. So let's look at LFM. I have it. Okay, yeah, I have it in my bookmarks. Let's see what loads. And so you can always go here and look at Liquid Foundation models. They have amazing models, right? And the models are not large. They are all, most of them are less than a billion parameters. So you can actually work with them on your mobile applications, embed them right inside your applications, and give amazing capabilities to your apps, and have your customers or users be very impressed by them. So you can also download them from Hugging Face. Essentially, you can get any open source model that you want to use in your application. You can get them on Hugging Face. Hugging Face is the platform where we go to download um, open source models, and you always look out for them in the GGUF format, because this is the format that you can get to use them, that are most portable, right? Where's the GLM? GLM is not here. Okay, let me use the GLM one time so that we have it in memory. So GLM 4.6, hello. So I'm going to, the hello should load it once. Once it answers me, it should pop up in memory. So yeah, with that done, let's do Olama list again and write on it, write on the money, JLM 4.6 cloud. I'll copy that, and let's go back to our how to. What does it say? So to start it up, I'll say Claude with the dash dash model, um, what they call it, inline arguments, then the model name. So Claude dash dash model, and then we'll specify the model and hit enter. So now you see that it's telling me that it's using this particular model, GLM 4.6 cloud here. But then, of course, because it was not built for GLM or open source, it's telling me that the behavior might behave somehow, but it doesn't behave somehow. It's actually good enough. So what would I say? I'll say, tell me about the product in this repository. What does it do? So let's wait. After this is done, I'm not going to I'm not going to ramble anymore, but I'll give that some time while it's reading what's going on there. We'll go back over, and this is completely free. because the usage limits are, but the usage limits are low, right? But then this gives you an option. You can also use this with essentially with any open source model. So like I showed you earlier on where I did Olama list, um, Olama list. So these models, the Ministral, the Phi, all these models that you can see the actual size are downloaded and sitting on my system. If I cut off from internet, I can use any of these models to still run ClaudeCode. However, the quality of responses will not be seen, which is why while this is okay, it's actually done. So it's a self-hosted document extraction platform that's local lens that transforms unstructured documents, PDFs, into structured data using AI. So this essentially the product I was telling you about. You can read it, you can pause and read it. If you need something like this, reach out to me and I'll set it up for your organization and air gap it because this is sensitive documents. And the reason why I prioritize making it self-hosted is so that you do not have to connect to internet or send your sensitive documents to a data center or an API endpoint somewhere. So for compliance purposes and ensuring that your data sits within your organization's environment, if you guys are doing anywhere upwards of let's say 500 to 1,000 receipts every month, invoices, contract review, anything that has to do with document processing and it's large and you need to extract information, structured information from documents, we can deploy this for you. You can get um, models from here, from Hugging Face, like I earlier stated. I wanted to show you the LFM vision model. These things are very well documented. So always look out for the GGUF format of the model, like I earlier stated. It's portable and it's easy to handle. If you also want to Dockerize your applications, you can package all of this together, drop it on the Google Cloud Platform, or deploy it to Azure or Oracle Cloud Infrastructure or any of the other cloud platforms, and then expose an endpoint to your organization's systems or internal information management system. That's if you don't want to buy um, GPUs. Oh yeah, I remember now. I wanted to show you what NVIDIA has done to make it what easy for you to have air gap systems. So if we look at the NVIDIA Jetson Orin Nano Super, yeah, this is what I wanted to show you. Once I show you this, I'm going to close out this session. So the Jetson Orin Nano Super computer is an AI computer that provides you 67 trillion operations per second, and that's at $249. So if you can get this kit, you are able to, if you have a model like let's say the M1, the M2.1. So let's look at Minimax M2.1. So the 2.1 at 16-bit quantization, it's at 457 gigabytes. So if you let's find some mid-range, let's look at the middle. So at 4 bits, you are looking at 130 gigabytes. So if you have a 256 gig SSD that you can attach to the Nano Super. The Nano Super comes with I think about with 64 gigs for you first of all install Ubuntu on it or any other Linux distribution, and then you attach the SSD to the hardware, and then it will be able to convert that memory into VRAM, where you can store this particular any of this version of the model. In fact, if you have like a 512, if you get like a 512 or 1 terabyte SSD, then you can get the 457 gig 6-bit quantized version, and then you can completely have an air gap system. You don't need internet. You no longer need to pay for you no longer need to pay for monthly subscriptions. And like I earlier stated, if you look at the software benchmarks, these open source models are not far off from the proprietary or closed source models. All of them are playing the same league right now. The difference is not much. So if you have produced a proper product requirement document with design documents for how your product or the issue that you want to solve, if you document it properly and feed it to this model, creating bite-sized subtasks for it to perform, then you can be rest assured that you will get the same results that you will get from any of the frontier paid versions or paid options of these large language models. So now that we've tested and seen how it works, I'm going to go ahead to show you how it would look like in VS Code. So VS Code is an IDE that just makes your life easier as a developer, right? Makes it makes for a better development experience. So if to install VS Code, it's free. It belongs to Google. So if you come over to just search for VS Code, download, I think the link will pop up quite easily. Um, where is it? Yeah, this is it. So I'm working on Windows, like I earlier said. So you open it up, download and install Visual Studio Code um, on Windows. Yeah, here's the installer. So you essentially just download this and then install it. It's pretty straightforward. The wizard is very intuitive. There's not much to guide you there. So I'll go back to the repository and open with code. So you would see that because I've installed ClaudeCode, VS Code already has like an integration um ClaudeCode. So in the chat window over here on the left, you see that the chat interface in VS Code will be activated. But if it's not activated, you can always use Control Shift and I. So Control plus Shift plus I. You press these three keys together, and then the chat window essentially opens up. I also have an extension for rule code. Rule code is also another harness. Like I was explaining earlier about how Cloud Code works, right? Rule code also allows you to use any model underneath to do all of your coding tasks and agentic development. So to test that Cloud Code is working, right? Like I said, well, if you type Claude and run it, it should open up immediately. So, but then it's using Sonnet 4.6, and what I've been trying to show you is how to use it with open source models. So I'm going to close this and ensure we have OLAMA with the necessary models, right? We'll be using GLM 4.6 Cloud. So I'm going to go back to Notion to show you the commands we're supposed to set in the environment. Oh, I didn't activate the environment. So CLS under activate. Um, I'm just going to use local lens for this. I don't want to create another environment. But like I earlier explained, you can use you can create any environment for you can create environments for all of your projects. So we're going to set the Anthropic authentication token. We're going to set the Anthropic base URL to tell Cloud Code where to find the model that it's going to be using to reason. And then we're going to set the API key to nothing. It's required, but only in only conceptually. So having said that, we'll now run Claude with the model, with the dash dash model parameter. We'll set the model to, let me see, GLM, right? GLM 4.6. I'm just going to copy it and paste it in here and hit enter. So now you can see something called GSD. This also means still going out of scope, but I think it's important that I also show you this. Earlier on in the early, I think late January, we were introduced to the concept of Ralph. So during agentic coding, we see that the developer has to like keep going through loops of approving whatever the agent is doing. You essentially have an autonomous agent that goes through your product requirement documents and then generates a set of tiny small tasks that it sets the pass criteria, right? It has a test to determine whether that small task has been completed accurately. So breaking down your tasks into like let's say about 10 or 20 smaller tasks, then the model does the agent goes through loops of picking each task, completing it, testing if it works, and then checking off if it is done or not. If it's done, it moves on to the next one, right? So Ralph loops were good, but right now we have something different called GSD, which is get shit done. It's essentially a Ralph loop on steroids. It has so much packed in there. So all I'm going to do is I'm just going to say get shit done. This is the repository. I'm just going to show you how to install it. You need to play with this, build something out for yourself, and then you see how powerful it is. So it's a node. It requires Node.js. So you've got to install Node. I think you should also be able to do that. If not, you can always reach out to me and I could give you direct. I can show you where to. In fact, you can essentially just go to Node.js download for Windows. Just search that. It's pretty straightforward and easy. If you install Node, then you have access to the npx command, which is what we'll be using to install get shit done. So the documentation here is very comprehensive. You can use it to do a lot. So you just copy this command and then install it and then restart your environment, right? So Node is pretty easy to install. You can come to the Node.js site. I think they have an official site here, right here. You go into this site and then you find the installer, download it, and then install it on your machine. So as for, let's go back to VS Code. So the get shit done has a lot of um a lot of functions. So you have slash functions, you have the GSD map code base. It goes through your entire code base to understand what your code base is all about. So I had mapped this code base earlier. When it maps the code base, it places it in a dot planning um, directory, and then the subdirectory in there is the code base, and then you can be able to see the architecture in Markdown. For this is basically LLM friendly, right? So any LLM can work with this. So if I now want to do any new thing, I can then essentially just say GSD new, um, let's say new milestone where you probably like update your project.md to like do something new. You can do a new project or you can resume work and then pick up from where you last were. Well, this is me just introducing GSD. You've got to work with this to be able to understand its power. But then you can essentially, I think I have Ralph loops in here. There should be this skill should be here. Okay, wait. Oh yeah, this is good. So these are the subtasks that Ralph loops like GSD give to you. So it essentially takes the entire task and breaks it down into user stories. So you have the title of the story, create jobs database, then the description, and then it defines an acceptance criteria. And then you can see that right now it sets whether it passes. It has been set to true, but then initially it sets everything to false. So the agent goes through loops, picking each story by ID one after the other, right? And then doing the task, which is create jobs database table, right? And then it uses this acceptance criteria to check if it passes. If it passes, then it sets this to true, updates the progress txt, right? The progress, I think there's a progress markdown somewhere that I can show you. Like this is like tracking what has been changed and then the time it was changed. So that even if you log out or you close out of this document, if you bring a different LLM, it can pick up smoothly and continue. So well, I've rambled a lot. I'm going off of scope. That is how you essentially use an open source model on a with Claude code, essentially. Thank you.